All right, thank you. So welcome everyone to this session about cloud native vector. I think it's a very promising session with packed of lightning talks. And we are going to start with Javier de la Torre. He's going to have a 10-minute talk to kick us off, and he will tell us about the race towards a fully native geospatial cloud. So over to you, Javier.
Can you say something, Javi?
Sorry, yeah, just trying to figure out in GoToMeeting. Can you hear me now?
Yeah.
Yes, we can hear you, yeah.
All right, well, then give me a second because I'm still also new to this GoToMeeting, so trying to find my way to share the slides. But can you guys see my slides now?
Nice.
Yes, we can. Yeah.
All right, great, 10 minutes. Great. Well, hi everybody, and thank you, Joanna. Very glad to be here. Thank you, Chris, and everybody for organizing the session. My name is Javier de la Torre. I'm the founder of Carto. My talk today is going to be on the Spatial Cloud Data Warehouses, something that I'm very passionate about. As you will see, also for some reasons of what we do at Carto, but also because I believe this represents a huge opportunity to rethink how we do geo on the cloud, and it opens a ton of opportunities to bring many more users to our community, which I think in the long term is what excites me the most, is to see our community of people that get to understand the power of geo and use it on a day-to-day. So, but let's get started. I was asked, because I might not be familiar to everybody, in our industry and for others, start by talking a little bit about what is the concept behind cloud data warehouses. There's many terms that you can find on the web around cloud data warehouses.
Sorry, Javier, I don't know if you want to put it in presentation mode, or is it intended like this?
I just don't think I can.
Okay.
Because
okay.
of
no worries.
Is it more or less?
We can see it. We can see it. Yeah.
So about it, the GoToMeeting privacy settings on a Mac and the nightmare of permissions. So if this works, that's great. So let's start, with a little bit of, what are these cloud data warehouses? I'm sure that most of you are familiar with at least a few of the logos that I'm putting in here of some of the commercial products. But I mean, you will find the cloud data warehouse defined in many terms on the web, from data warehouses to data clouds to databases to data lakes to many different ways. But in essence, I mean, they are think of them like databases or data warehouses that are optimized for analytical purposes, right? And there has been, over the last, I would say, probably 6 years, a huge revolution on this space, where now we're starting to see more and more products coming that heavily benefit from cloud technology. The same thing that we've been talking over these 2 days around cloud capabilities. Well, so these products are the next generation of data warehouses that really liberates the cloud capabilities. As a reference, there's a few leaders on the market. Obviously, the cloud vendors themselves are very strong players there. Each of them have one or more cloud data warehouses products that they offer on their own. AWS has Redshift, but it also offers Athena and a number of other products that could be categorized in the same space. Google Cloud has a very big proposition around BigQuery. Azure has also multiple products, but Synapse Analytics seems to be also what they are surrounding around themselves. And then there's 2 products on the commercial landscape that are really growing very fast, which is Snowflake. You probably heard, one of the fastest growing enterprise software companies recently, and Databricks, which you probably are very familiar around the Spark ecosystem. And those 2, Snowflake and Databricks, work on multiple cloud. So they're cloud agnostic or cloud independent, right? So this is the thesis. Then there is a lot of other open source projects that I can mention, that also fall within this space. But I think it's fair to say that the rise of the data warehouses is mainly driven right now by the commercial providers attached very much to the cloud vendors and the relations they have with them. And this market is growing now like crazy. It's probably one of the fastest growing segments on enterprise software that you can find. I mean, you've probably heard of a Snowflake IPO and the valuations and so on, but so it is on any cloud company that is pushing on this segment is benefiting a lot. And the reason for it is that they're seeing massive adoption. from users. These products are really attracting a lot of users to rethink the way that they do analytics on their organization. From my point of view, they are really responsible for, in a way, democratizing or making accessible the power of cloud, scalable cloud computing to many more to many more people than it's been previously before done. So just for you to get an idea, this is how they look like. They look like databases. So this is BigQuery on the top left, Snowflake right, Redshift, and Databricks. They're essentially kind of like they now there's a very clear trend towards like exposing, as we would talk, a SQL interface where you essentially operate with them in SQL. Some of them, like Databricks, come more from also like supporting Python, Scala, as you know, within the Spark ecosystem. But now also Snowflake is adding Python support to interact with them, and so the others. And these products are competing now like crazy, and they're like doing feature matching all the time. So what you see on one is coming to the others, etc. Now, why they are so popular and why it's so important? The first is that they provide huge benefits to users because of the usage of the cloud. So a lot of them, you're probably familiar with them. The scalability is obvious. These products allows you to essentially, they can parallelize and utilize depending on the product, but most of them, like in a serverless capacity, they can open up servers and and increase the capacity for analytical workflows. And you get the scalability, in some cases running thousands of machines at once, right? To run your queries or to run your analysis, right? That's one. So scalability is very big, and it's a scalability, accessible scalability. You don't need to create a map reduce work. You just write SQL and it will take care of all that. So that's a massive advantage. The second one, they're pretty cost effective. And this is a very, very important factor when we're talking is storage computing separation. The fact that you run SQL, but the data is not in memory, it's not in your RAM or your it's not like a PostgreSQL database, if you want to say. It actually, the storage is in the cloud storage, S3, Google Cloud Storage, Blob Storage, etc. And we'll talk a little bit more about it. But that essentially means that when you are not using the data, when the data is only just sitting there, without being used, you're paying only a storage cost at cloud storage prices that is very, very competitive, right? So that's a huge, huge cost-effective benefit, but also it has other implications. I'll talk about data multi-tenancy. These first two, I think, are pretty well known. Data multi-tenancy might be less known, but it's a huge benefit that they provide you. I'll go over it. But essentially, they provide data sharing between different users in a very, very effective way. And then finally, they are essentially becoming very kind of like central points to a lot of data workflows, so they enable a lot of interoperability. And I'd like to talk a little bit about them. But I will do it on the context of geo, because this is really what is exciting. Over the last 4 years, we've seen like many of those products starting to add more and more spatial capabilities to them, right? So BigQuery was the first main next generation data warehouse that added the spatial support. Then came Redshift, the Snowflake, and pretty much now all of them have some support of a spatial capability in the form of a spatial functions, right? And one of the things that this enables, it's going back to the point around data multi-tenancy, is that this computer storage separation is enabling what we call the world of data serves. It's like we all live in a single database. I have my database on one of these cloud data warehouses. Let's think about saying something like a Snowflake, and I can share a table with another user in the concept of something called data shares. And of course, since my data and the other user are also on the cloud, we essentially, it's a logical share. There's no data transfers. And that's a huge change on the way that we think about distributing data. So I like to put this concept of, I really like this, it's very pseudo SQL, but think about like you have your own data and you need to do a SQL where you're joining your data with 3 providers and you want that data to be always updated and you don't want to do ETLs. This is possible in this kind of like ecosystem with the concept of the data source. And this is what we call like putting here, and this is very nice connected to later, Joris is going to be talking, but one of the issues that we had with this is that these data sets and this concept of storing the data on cloud storage and then using it from these computing engines, from these data warehouses at the top, was already possible, but was not possible on Geo. And for that, we needed another piece of interoperability that we've been working out for quite a bit of time, which is GeoParquet. Chris, Joris, and a number of people in many organizations have been working on this, which is how we can make geospatial support in the Parquet format, which is a very well-known format supported by all these data warehouses, so that providers like Carto, Foursquare, Planet could potentially publish their data sets on these GeoParquets, and then you can use them directly without necessarily moving into your place, directly in your same SQL as I'm describing. This is one of the core advantages of having interoperability at this level. That I believe alone, it will be a huge game changer in the way that we think on Geo. But that's not only the only one. I was talking about also SQL, right? SQL being like this power for interoperability. SQL is really becoming the lingua franca between on the world of data analytics, and probably it's because of the rise of these type of data warehouses. So now you have like products that do ingestion, preparation, transformations, enrichments, all of those, all the steps that you can think of almost on data analytics. Now there's products that do that through the use of SQL. And what this means that now suddenly you have a lot of interoperability because of products, because they're just using that as the same like language for passing from one place to another. And now going back to the spatial, well, the capabilities when it comes to Geo are growing really fast. So PostGIS obviously is the most mature kind of like database system, if you want to say, with spatial support. But Redshift, BigQuery, Snowflake, they're all like competing a lot to try to add more and more spatial capabilities. So it's just becoming better and better every day. In fact, actually part of that, one of the things that's just gonna wrap up in there, we do create an open source product that has also a commercial component, but like it's called the Analytics Toolbox, where we're trying to advance actually the capabilities of these data warehouses into.
Sorry, Javier, we are coming to the end of the time. I mean, if you could just wrap up.
That's the last thing I wanted to say. So
okay,
it's actually open source. You can go to the Spatial Extension finding. Thank you very much.